lesson 2 is about geometric progression. Let us see what we can do with the geometric progression. Now, a geometric sequence is one in which the ratio of the successive terms is constant. What I mean by that? You look at these examples here, if this is 3, and then you're multiplying by 2, you're going to get 6, and you're multiplying by 2, you're going to get 12, and you're multiplying by 2, you're going to get 24. That means the ratio of each successive term, if you're dividing all of this with the previous term, you are going to get 2. Therefore, this is a geometric progression. Now you can look at this one. This is 4, and then it will be minus 2. That's actually you are multiplying by negative half. Again, you are multiplying by negative half. You are going to get 1. Again, you are multiplying by negative half. You are going to get minus 1 over 2. So therefore, geometric progression or geometric sequences. Now, in general, a geometric sequence looks like this. If you have a first term A, and then this is A times R, therefore you are multiplying by R, and then you are again multiplying by R, you are getting R squared. If you are multiplying this by R, you are going to get R to the power of 3. Therefore, A is the first term, and the R is called the common ratio. Therefore, this is the common ratio, and this is the first term. Now, let us see one example. We want to know which one of the following sequences are a geometric progression or geometric sequence. Look at this. This is 1, then you are multiplying by 3, you are going to get 3, and you are multiplying by 3, you are going to get 9, and then you are multiplying by 3, you are going to get 27. Therefore, this is a geometric progression. Now, let us look at the second one, 125. If you divide or multiply by 1 over 5, you are going to get this. Again, multiply by 1 over 5, you are going to get this. Again, you are multiplying by 1 over 5, you are going to get 1. And then again, multiply by 1 over 5, you are going to get 1 over 5th. That means this is a geometric progression. Now look at this. This is 24. Now you are dividing or you are multiplying by negative half, negative 0.5. Okay, you are going to get minus 12. If you are multiplying by negative half, you are going to get 6. Multiplying by negative half, you are going to get negative 3. And then the last one will be 3 over 2. Therefore, this is also a geometric progression. Now look at this. Here, you are multiplying by half, you are going to get 3. When you are multiplying this by half, you are not going to get 2. Therefore, the last one is not a geometric progression. So, let us see what we can say about the geometric progression. Now, general term of or nth term of the geometric progression is like that. Let us assume that A is the first term and the common ratio is actually R. Now, the first term is A, second term will be AR, and the third term will be AR squared, and the fourth term will be AR to the power of 3. You can see that each time I'm multiplying by R to get the next step. But look at this, always the index here, the first term there is no R, the second term there is 1 R, the third term there is 2 R, the fourth term there is 3 R. Therefore, the nth term should have n minus 1 R. That means this number here is always one number less than this. Okay, therefore this is your nth term. The reason is that the first term doesn't have R, therefore the nth term should have n minus 1 times multiplied R. Okay, R to the power of n minus 1. Okay, now let us see. I worked out the example. Now look at this. In a geometric progression, the fifth term is 162. And the third term is 18, okay? If all the terms of the sequence are positive, find the first 5 terms. Now we want to find the first 5 terms. Let us see how we can find the common ratio and first term. Now, what we know is that the fifth term is this. That means AR to power of 4. You should remember that. It should be always 1 less than this. Therefore, AR to power of 4 is 162. And because it's the third term, it will be AR to power of 2 is 18. You can see actually you are having a simultaneous equation, 2 unknowns with 2 equations. You need to solve this. But the best way to solve when you are doing this geometric progression is that just divide them. If you are dividing this by this, and so that you are dividing this by this, you are going to get A get cancelled, R also get simplified. Therefore, here I'm dividing both sides. Therefore, a and a get cancelled out. R to power of 2 cancels this, will be r squared. And this, you're dividing, you are going to get 9. Therefore, you are getting r squared equal to 9. Therefore, r is equal to plus or minus 3. Since all the sequence terms of the sequence are positive, no need to put negative 3 only. Negative 3. Therefore, the answer is only 3. Therefore, this is the r. Now, if substitute this r here or here, but here is simpler, you are going to get the value of a. Therefore, a will be equal to 3 to the power of 2 times 18. Therefore, this is 9. 18 divided by 9 is 2. Therefore, a is equal to 2. Therefore, first term I know. Now, since I have first term, I have first term, and I have r, I can write all the terms. Now, the sequence start by 2, and then you have to multiply by 3. You are going to get 8. And then you are multiplying by 3, you are going to get 18, which we knew already. It is given in the question. If you are multiplying again this by 3, you are going to get 54. And if you are multiplying again this by 3, you are going to get 162, which already we knew that. Okay. So these are the first 5 terms of the sequence. Now we're done with this question. Now let's go for next question. Now here, it says that first term of the GP is 12 and the second term is 6. Okay, good information. Find the first 5 terms of the sequence. Okay, we can do that. Then they're asking us, are the terms of the sequence in a descending order? Let us see. Do the terms of the sequence approaches to 0? Let us check that. Let us go one by one. The first you want to find is, for finding that, I know the first term, I need to find the second term. Therefore, easily I can find the common ratio. How to find the common ratio? As I told you, you can divide them. Therefore, if divide second term by the first, second term by the first term, you are going to get the common ratio. Therefore, this is AR divided by A. You are going to get 6 divided by 1 over 12. You are going to get 1 over 2. So the common ratio is 1 over 2. Therefore, each time I have to multiply by 1 over 2. Now, therefore, this the first one is 12. Then second times will be 6. And the third term will be this multiplied by half will be 3. Again, if I multiply this by half, I'm going to get 1.5. Again, multiplied by half, I'm going to get 0.75. You can see the terms of the sequence are decreasing. Therefore, the answer for the next question is yes, the terms of the sequence are decreasing. Now, what it says here, the last question, do the terms of the sequence approaches to 0? That means these numbers are going closer and closer to 0 or not. It clearly does, because every time we are dividing these numbers by 2, therefore the magnitude of this number reduces in each term by half, so that they are approaching to 0. Okay, you can say yes, terms of the sequence are approaching to 0. Okay. Now, some of the terms of the geometric progression. Now we are going to find the sum of them. That is a series actually. Now, look at this, the sum of the n terms of a geometric progression. Now, as usual, let A be the first term and R be the common ratio. Therefore, the terms will be like that. Now, this is the series. That means you're adding the terms of the sequence. We call it series. Therefore, now we are adding them. Therefore, the first one and plus second one and goes on till the nth one. Therefore, these are the sum of the nth terms of the sequence. Okay, now I will multiply all of these by negative r. Therefore, if I multiply by all of them by negative r, this will be negative AR squared, negative AR cubed. And here you are going to get 1 before this, I'm going to get negative AR to power of n minus 1. And this will be negative AR to power of n. Now, if I just add them, here I'm going to get 1 minus r Sn. Therefore, this 1 minus r Sn. You can see that this term will remain. All of other terms, they will cancel off. This also goes off. Only this will remain. Therefore, this will remain here. Therefore, from here, A will remain. From here, minus A r to power of n will remain. Factorize A and divide this, you are going to get this. Therefore, this is the formula for sum of the n terms. That means if you put any values for n in this formula, you are going to get the sum of the first n terms. The first n term. Therefore, this is the sum of the first n term. Okay, now let's go for the next. Now, another worked out example. In a geometric progression, the first term is 48 and fifth term is 3. Okay, now let us see what he's asking. Find the common ratio, find the 10th term correct to the three decimal places, then do the terms of the sequence approaches to 0, find the sum of the first 10 terms. If all the terms of the sequence are positive, then find the sum of the first 10 terms if all the terms of the sequence are not positive. Okay, let's go for the solution. Now, we know that U5 is 3, U1 is this. U5 means what? U5 means AR to power of 4, then A is 48. Therefore, I will divide this by this. Therefore, 3 divided by 48, I'm going to get R to power of 4 is equal to 1 over 16. Therefore, A is plus or minus 0.5. Therefore, this is plus or minus 0.5. Now, I need to find the 10th term of the sequence, correct to 3 decimal places. Therefore, I need to find the 10th terms. 10th term of the sequence, then what should I do now? Therefore, 10th term is equal to AR to power of 9. So this is either U10 will be equal to 48, which is the first term, times 0.5 to power of 9. Okay, just put in the calculator, you are going to get this is correct to 3 significant figure. But if you are using the negative number, you are going to get the 10th term negative of 0.94. Therefore, you can see that both these numbers are very close to 0. So the second term is asking whether the terms of sequences, the terms of the sequence approaches to 0. Both of them are approaching to 0. One of them decreasing to 0. One of them oscillates towards the 0. Therefore, that means one is positive, one is negative, but they are going closer and closer to 0, and this decreases to 0. Okay, therefore, both of them are approaching to 0. Now, S10 will be equal to, what was the formula for that? Will be A1 minus R to power of N divided by 1 minus R. If we just put in the calculator, you are going to get 95.91. Now, if you are selecting the other R, for the other R, that means R equal to negative 0.5. Therefore, here you are going to get 48, 1 minus negative 0.5 to power of 10, which doesn't make a difference, but here is the difference. 1 minus 0.5, this will be different value from here. Therefore, now you can find this. You are going to get 31.97. Therefore, that is dependent to the value of R. The S10 will be different. Okay, this is done. Therefore, we have done. Note, limit of the terms. Now let's see what you mean. Okay, you see in the geometric progression, if terms of the sequence with the modulus of R less than 1, that means the common ratio of these sequences are a fraction of 1, maybe negative, maybe positive. The terms approaches to 0 because actually we are multiplying by a fraction. Therefore, each time the term will reduce if they are positive. If they are not positive, they will oscillate towards the 0. That means sometimes it's positive, sometimes it's negative, but they are going closer and closer to 0. Therefore, modulus of less than 1 is very important factor in geometric sequences that makes the terms goes towards the 0. Now, write down first 5 terms of the following geometric sequences and determine which one of them approaches to 0. Let us see what is this. Now, U1 is this, U2 is this. That means each time I'm multiplying by half. Let me write all of these. Now, these are the sequences is given to us. Now, first one you are multiplying by half. Therefore, then again, I have to multiply by half. I'm going to get 50 and then go on like that. Therefore, this one is 50 times, then the next will be 25, and then next will be 12.5. You can see, even the number you started, the big number 200, you can see it is grown, it is reducing towards the 0. Therefore, if you are continue multiplying by half, it approaches to 0. Therefore, the first term doesn't matter. The value of r is important because the r is a fraction. It will keep on reducing the terms till approaches to 0. Now look at this. Even this number here, the second one, you are multiplying by 2. When you are multiplying by 2, see, first one is this. This is the first one. The second one, okay, we are applying by, you are multiplying by 5. If you are multiply this by 5, you are going to get 1.5. If you are applying this by 5, sorry, negative 5. Negative 5, you are going to get negative 7.5. And again, you are applying by negative 5, you are going to get 37.5. You can see that the terms are started very small, but it is growing and growing and growing. It grows to infinity. That means the R is the most important factor in the growth of this in this sequence. So look at this here. Now look at here. Then when you are having something like that, that means you are actually dividing by negative 4. You are dividing by negative 4. Okay, if you divide this by negative 4, even though you started with 1000, if dividing by negative 4 is this, then you are dividing by negative 4, you are going to get this, and then you are getting to get negative 16 and 4. And then if you continue, you're going to get 1, negative 1 plus 1 over 4, or goes on like that. You can see they are reducing toward the 0, but it oscillates toward the 0. Okay, for the last one, also you can see that even though it's small, but you are multiplying each time by 3, therefore it's growing to 16. You can see that this grows to infinity. So all these examples is for this, you have to understand when r is equal to 0, the terms, r is a fraction of 1, doesn't matter positive or negative. The terms of the sequence will approach to 0. When r is more than 1 or less than negative 1, the terms of the sequence goes towards the infinity. You can see that they are growing. They are growing, both of them. Okay. Now let us see. Now, there's one example here. There's one question here. It says that A, B, and C are 3 consecutive terms of a geometric sequence. Show that A times C is equal to B squared. Now, there are different ways of solving this. If you are like, you can pause the video and try your own method. But if after, you can check my answer also. There are different ways. You may go other, you can use other method also. But I found it to do it this way is the easiest one. It's because by the definition, if I divide B by A, I'm going to get R. If I divide C by B also, I'm going to get R. Therefore, I can say that because we know that they are the consecutive terms, then if you divide them, you are going to get the common ratio R. So we know that B over A is equal to R, and then C over B also is equal to R. So that these two should be equal. Therefore, B over A is equal to C over B. Just cross multiply this, you are going to get B squared equal to AC. Therefore, we got the answer very fast. Therefore, it was not a difficult question. Just you have to remember the property of the geometric progression. That means what is the main idea of that? That means that if you are dividing any term by the previous term, you are going to get R. Okay, this is done. Now, sum to infinity. Now, that is why we discuss a lot about this fraction and all these things. Now, you know that if the terms of the sequence GP tends to 0, the common ratio R is a fraction of 1. That means it's between 1 and minus 1. In other words, R is between negative 1 and 1, or absolute value of R is less than 1. Or you can say modulus of 1, R is less than 1. Anyhow, that means R is a fraction of 1, can be positive, can be negative. In that case, you can see that the sum to infinity, sum of the infinitely many terms of the sequence exist, or can be said the series converges. Remember the word converges. It converges to a value. What is the value? Sum to infinity is A divided by 1 minus R, because R to power of n, which you are having here, R to power of n, which you had in formula, it tends to 0, as we discussed before. Okay, because it's a fraction, when the power increases, the number reduces. Therefore, the sum to infinity is a divided by 1 minus r. So we have this formula, sum to infinity. Now let us see. Now we can look at this. Consider the geometric series this. Therefore, this is a geometric series. Why it is geometric series? Because each time I am multiplying by half. You can see that each time I'm multiplying by half. Therefore, r is equal to 1 over 2. First term is equal to 1. Now he's asking, find the sum of the first 30 terms. Okay, we can do that. Find the sum of the sum to infinity of the series. Okay, we can find the sum to infinity of the series. Find the sum of the first 50 terms of the sequence. Okay, compare the result and give your conclusion. Okay, then let us see. Therefore, first he's asking to find sum of the 30 terms. Okay, sum of the 30 terms, we have a formula for that. We know the formula, Sn is equal to a 1 minus r to power of n, 1 minus r. Therefore, you want to 30 terms. If you are substituting 30, you are going to get this number there. Therefore, 1.9999, very close to number 2. Okay, now let us see what is sum to infinity. Sum to infinity means a divided by 1 minus r. Therefore, a is 1, r is 0.5. Just substitute, you're going to get 2. Therefore, that means sum to infinity is 2. Okay, let us see, calculate this. Now, if you are putting your calculator, you are going to get 2. Okay, therefore sum of the 50 terms also says is equal to 2. Okay, is this correct or wrong? Let us discuss about this matter. Now, you see here, I've written the conclusion. The issue is that when you're writing sum to infinity, your calculator has a problem. That means the calculator has an approximation. That approximation is so small so that your calculator says it is 2, but it's not actually 2. Perhaps it is 1.999, some 10 more nines are there, then there is 8 there. Therefore, that means these are approximate. They are less than 2. This also is less than 2, but it's so close to 2, which is your calculator just, says it is 2. So when you are saying sum to infinity is equal to 2, that means if you are adding the numbers, when you keep on adding the numbers, the sum approaches to number 2. You can see it's so close to number 2, and this is so closer to number 2, which your calculator cannot calculate and says, okay, leave it the approximation, and he says it is 2. So that you remember when you are saying sum to infinity, this means if you are keep on adding the terms, the sum will approach to number 2. Okay, that's the meaning of this sum to infinity. Okay, we have done with this question. Also worked out the example. Another one, third term and fourth term of a GP are 48 and 32 respectively. Therefore, we have third and fourth term. Okay, find the common ratio. It's very simple to find because we know this third term we can find. Find the first term of sequence. That's also okay. We can find that. Does the geometric series convergence? Y? Okay. Then find the sum to infinity of the progression. Okay. Actually, when they are asking some question like that, immediately you can say this is yes, therefore, because they're asking us to find the sum to infinity. Okay. Anyhow, let us go for the answer. Third term and fourth term, they have given 48 and 32. If you like, you can pause the video and do the question by yourself, and later on you can compare your answer with my answer. Now, here also is asking find the sum to 50 terms of the. Okay, let us go to for the solution. Okay, now we know that they are consecutive terms, therefore you can divide them. 32 divided by 48, you are going to get the common ratio. Because they are consecutive terms, just divide this by this, you are going to get the common ratio. Now we have the common ratio. You know that the common ratio is less than 1, so the common, he is asking to find first A. Therefore, we know that the third term is 48, the third term is 48, therefore A 2 to the power of 3, therefore you can just simplify this and get the A is equal to 108. Or you can use 32 also. In that case, you have to use the formula for that, the power with 3. Doesn't matter which term you are using. Therefore, this is the third term. You can use the fourth term. Easier to use the third term. Okay, we have done this and we got the answer. Anyhow, now we know that this is less than 1. so the sequence converges. The reason is that this number is a fraction of 1. It is less than 1. Okay, that is correct. Therefore, we know this. Now he wants the sum to infinity. Sum to infinity will be a divided by 1 minus r. A is this much. 1 minus r is this. Therefore, the sum will be, just put in the calculator, you are going to get 324. Therefore, you got the value of this. Now you can see that. Now Sn is equal to. Now we are going to find the sum of the 50 terms. Now sum of the 50 terms, if you are putting 50 here in the power, a is 108, and this is 1 minus 2 over 3 to over 50 divided by this. You can see that so close to 324. That means, as I told you, whenever you are keep on adding the numbers, this number approaches to this sum to infinity. Sum of the 50 terms is so close to this number. So that is the meaning of this, and this is sum to infinity. Okay. Okay, here's another worked-out example. In a GP, sum to infinity is double, oh, sorry, this is of the first step. Of the first step, the typo error, this is of the first step. Okay, find the common ratio. If the third term is 12, find the first term and the sum to infinity. Okay. What is the least number of the terms where the sum of the terms exceed 47.9? Therefore, this also is wrong. This is term. Or some of them, okay, can also. Some of them exceed this, correct? Therefore, now, we know that sum infinity is equal to 2 times of a. Therefore, sum infinity is, this is the formula. It says that here the sum to infinity is double of the first term. Therefore, this is double of the first term. Therefore, a divided by 1 minus r is equal to 2a. You can cancel off a from both sides. Therefore, 1 divided by 1 minus r is equal to 2. Therefore, r is equal to 1 over 2. Therefore, we have got the common ratio. So it says that the third term is 12. Therefore, the third term means actually the third term is u3, means a times 0.5, which is r to power of 2. Therefore, this is actually 1 over 4. Then you multiply this side with 12 divided by 1 over 4. You are going to get a is equal to 48. Therefore, the first term is 48. Now, now you want to find what is the, find the first term and the sum to infinity. Now you want to find the sum to infinity. Sum to infinity just is here. We know the formula S is equal to, okay, I have not done sum to infinity, will be double of this. Therefore, 2 times of 48 will be actually 106. Therefore, the sum to infinity will be 106. Just you put it here. A is this much, will be double of this. Therefore, sum to infinity is done. Okay. Therefore, we are going to do the last question here. What is the least number of the terms where the sum of them exceed this number? Therefore, sum is this. This should exceed the number 95. Okay, now we have another example. We are doing this next example. In GP, sum to infinity is double of the first term. Sorry, this is an typo error. Therefore, this type of error. Therefore, this is off, not OD. Okay, doesn't matter much. Find the common ratio. Therefore, then here in the if the third term is 12. Now find the first term of the first term and sum to infinity. Now, what is the least number of the terms where the sum of them exceed 95.9? Now let us go for the solution. Now we know that sum to infinity is more than 2a. That means a divided by 1 minus a is equal to 2a. You can cancel off a, therefore you are getting 1 over 1 minus r is equal to 2. Just simply you can cross multiply and solve this equation. Linear equation easily can be solved, and you can see r is equal to half. Now r is equal to half. Now third term is 12, therefore third term is 12, therefore u3 is equal to a times 0.5 to the power of 2 is equal to 12. This is 1 over 4 actually, to power 1 over 4, therefore you are just divide this by 1 over 4, that is actually you are multiplying this by 4, you are going to get a is equal to 48. So the first term is 48. Now sum to infinity is double of this, therefore there will be 2 times of 48, which is 96. Therefore we have done this, 96. Now he wants to know what is the least number of the terms where the sum of them exceed 95.9. Therefore, what is that? You know the formula. N is equal to a 1 minus r to the power of n divided by 1 minus r. This should be more than 95.9. Well, we know a, we know r, the n is unknown. Therefore, what we are going to do, just substitute the number here, simplify this. This is half, therefore this is multiplied by this. You are just multiply this, therefore you can divide this number. You're going to get 1 minus this equal to this much. Okay, then after that, you take this that side, bring this side, simplify this. You're going to get 0.5 to the power of n is equal to 1 divided by 960n. Whenever the unknown is in the power is unknown, therefore this exponential equation, the only way you can do, take any kind of log from both sides. Therefore, it is convenient for me because take the ln. Therefore, ln of n is this much. Now, when you are to get the n, you have to divide both sides by ln 0.5. Now, remember that this number is a fraction number, therefore the ln of the negative number. Therefore, since it is a negative number, this will change. This will change, the sign will change. Therefore, n will be more than ln of this divided by this, which you can put in calculator. You are going to get more than 9.9. Therefore, the least value is n equal to 10. More than 9.9, it should be 10. Therefore, the answer is n equal to 10. This is the least value. When you're getting exceed, the sum get exceed from 95.9. Okay, remember the important fact that whenever you are solving any exponential equation, you need to take log from both sides. And another important fact is that when you are dividing both sides by any number, when you have inequality you are dividing, you have to make sure this number is positive or negative. Since it is negative, this sign will be more than. Therefore, now just I put this number in the calculator, divided by this number, then I got the value this much. Okay. Now, there's another workout example here. A pendulum is set swinging. Its first oscillation is through an angle of 20 degrees, okay? And each following oscillation is through 95% of the previous angle. Now, after how many swings is the angle through which its swing is less than 1 degree? What's the total angle it has swung through? Okay, we have got this question like that. Okay, now let's see what you want to do. Now, the angle of the oscillations are a geometric progression because each time you have to multiply the previous one by 95%, which means, sorry, which means r is equal to 0.95. And the first term is 20. Therefore, we have all these things. Now, therefore, we want to know after how many terms, then this is less than 1 degree. Therefore, this is a r to the power of n minus 1. Okay, just we can substitute. A is this much, r is this much, to the power of n minus 1 should be less than 1. So I will divide this by here, then I'm going to get 0.95 to the power of n minus 1 is less than 1 over 20. Now, as I told you before, now I need to take ln from both sides or any other kind of log, doesn't matter. Ln from both sides. Now then this n minus 1 comes as the coefficient, is the property of any log. Therefore, now I need to divide both sides by ln n ln 0.95. And again, you have to remember it's a negative number because it's a fraction. Therefore, this will be more than. Therefore, n minus 1 is more than this. You are putting the calculator, you are going to get 58.4. Therefore, you are taking one that side. Therefore, n should be more than 59 point something, which will be n is equal to 60. Therefore, the least value of n is 60. That means the first time after 60 oscillation, this is the first time which that the pendulum oscillate less than 1 degree. Now, let us see what is the last part of the question. Now, if we assume it has swung infinite times, therefore, if we assume it has swung infinite times, that means after some time, we just, as we have discussed, so terms are so small, we can neglect them and assume that all of them is the sum will be sum to infinity. Therefore, now we can use the s to infinity, a divided by 1 minus r. Therefore, a is 20, r is 0.95. Therefore, just you can substitute it here, and then you get this number 400 degree. This pendulum is swung. That means it approaches to this number. Okay. Now, work out example again. The sum to infinity of a GP is 9 times the sum of the first 4 terms. Given that the first term is 12, find the value of the 5th term, okay? Now, let us see what we can do. Okay, sum to infinity is this, is 9 times of this, okay? This is the first 4 term, a plus r squared, and a plus r cubed. Now, I have multiplied this that side. Actually, a can cancel off from both sides. I can cancel out, okay, therefore this will be 9a. I'm dividing 9a this side, therefore I'm going to get this. You can see that if I expand this 1 times, I'm going to get this. Then when I'm multiplying this by negative, I'm going to get all of this. Therefore, this is, if you're expanding, you're going to get this. Therefore, this is 1 minus r to the power of 4. Therefore, this is 1 minus r to the power of 4. Therefore, a cancels r, so r to the power of 4 is 1 minus this. Therefore, r will be r to the power of 4 is this. Now it's asking us to find the fifth term. Therefore, fifth term is actually u to the power of u5 is 8 times r to the power of 4. Therefore, no need to calculate r actually here. So the fifth term will be this. Therefore, r to the power of 4 is this much, and 12 is the first term. Therefore, 12 times this. Therefore, I'm going to get 32 divided by 3. Therefore, this is the fifth term of this sequence. Okay. Okay, this was the last question for this lesson. I hope you have enjoyed this lesson and you have understood what is a geometric progression. If you have any doubts or if you want to ask any question, you can put them in the comments, and I will look at them and I will try to answer your question.